Hello everyone. In this video we're going to be dealing with an algebraic expression. We have x plus 1 over x equals -1, and we're going to evaluate for these values of x, we're going to evaluate x to the power 18 plus 1 over x to the power 18. I'll be presenting three methods, even though the first one will be incomplete, and you'll see why. So let's start with the first one. So for my first method, I want to make a common denominator and then multiply both sides by x and then put everything on the same side. Now, if you solve this quadratic equation using the quadratic formula or otherwise, you're going to get complex roots, non-real complex roots. Let's go ahead and write it. X equals -b plus minus the square root of b squared, which is 1 minus 4. That will be a -3, so you can write it as square root of 3i, and that is divided by 2. So as you can see here, the roots are non-real. Suppose you go with the +1. So like this, right? It doesn't matter which one you use, but let's say you use the positive version. Now you are going to substitute this into the expression, which is x to the power 18 plus 1 over x to the power 18. And good luck with that. You're going to raise this to the 18th power. Of course, you don't have to do it directly. There's other ways to do it, and we'll talk about those much better methods. So this method is not a really good idea, but again, still a method. All right, let's talk about the second method. So we're given again x plus 1 over x equals -1, right? And we're trying to evaluate x to the power 18 plus 1 over x to the power 18. Now these kinds of expressions are very common in math competitions and Olympiads. That's why it's important to know these identities or how to work with them. Okay, so here's my how my second method works. I want to get to the 18th power by raising this original expression to different powers. And here's one way to get there. I can cube this and get x cubed and 1 over x cubed, and then cube it again, and that's going to give me the 9th power. And then if I square the 9th power, that'll give me the 18th power. Make sense? So start with the first power, cube it, get that 3, cube it again, get a 9, and then square. So this is like cube, and then square. Those are the operations basically. Make sense? Okay. And if they ask for the 17th power or 19th power, we would do things slightly differently, but it's the same idea. Okay, so let's go ahead and start by cubing this expression. So one thing to remember, if you are cubing a binomial like this, it's always helpful, almost always, to use this special identity. And you know that we use this for cubic formula, right? I don't want to say Cardano's formula because it's not his, but anyways, that's a different story. So yeah, this is a really helpful identity. So if we use that, notice that 3ab is 3 times x times 1 over x, which becomes a 3 automatically. So we don't have to write it, we can just write a 3. So anyways, this becomes x cubed plus 1 over x cubed plus 3ab, which is 3, times a plus b, which is x plus 1 over x. Now this is nice because we do know x plus 1 over x is -1, so we can go ahead and plug it in. Let's do it. So this is -1 and this is -1. So from here I can find x plus 1 over x cubed plus 1 over x cubed, because all I have to do is -1 cubed, which is -1, equals x cubed plus 1 over x cubed plus 3 times -1, which is a -3 or a -3. If you add 3 to both sides, you get x cubed plus 1 over x cubed equals 2. Great. So we got the sum of the cubes, sort of. And now we're going to cube this again. And maybe I shouldn't frame that because I'm going to cube both sides. Okay, let's do it here. Cube and cube. Again, we're going to use the same identity, this time a and b being x cubed and 1 over x cubed. So it's going to be x to the 9th plus 1 over x to the 9th plus 3ab, that's going to be 3 again, no matter how high the powers are, times a plus b, and that's going to be 8. Now remember, we know this x cubed, let me rewrite it, because we cubed it, so we don't see it necessarily. So we know that this is equal to 2, right? So this is 2. 3 times 2 equals 6, and 8 minus 6 is 2. So it also makes this a 2. Okay, great. X to the 9th plus 1 over x to the 9th is also equal to 2. Now we're going to get to the 18th power, so let's go ahead and square both sides, because 9 times 2 is 18. Makes sense, right? Hopefully. X to the power 18 plus 1 over x to the power 18 plus 2ab. This is squaring, not cubing, so you're going to use a squared plus b squared plus 2ab, and that is going to be a 2, and that's equal to 4. And from here you get x to the power 18 plus 1 over x to the power 18 equals 2. And that will be the answer. 4 minus 2. Make sense? We just go ahead and subtract 2 from both sides, and that gives us the answer. The first method is fairly long because you come up with a complex number, a non-real complex number, and raising it to the 18th power. Couldn't we raise this to the second or third power? Absolutely. Oh, by the way, a method that we didn't talk about, that would probably be the fourth method, and I'm hoping that somebody will talk about a fifth method here, would be to write this as a complex number in polar form. That would be really awesome, actually. Let's briefly talk about it real quick, and then I'm gonna show you the third method. Okay, so this one, since x can be written as -1/2 plus square root of 3 over 2i, so we're kind of thinking about an angle whose cosine equals -1/2 and whose sine is root 3 over 2. If they were both positive, the angle whose cosine is 1/2 would be 60 degrees or pi over 3. But this is in the fourth quadrant, right? Am I right? No, it's actually second quadrant because x is negative and y is positive. So we have to reflect it. In other words, we have to subtract it. So in this case, the alpha would be 2 pi over 3, and you could basically write x as cosine 2 pi over 3, and then I sine 2 pi over 3. And in this case, it will be a lot easier using the Moivre. I always call it the Moivre, whatever. I can't say the other one. The French version would be a lot easier. Okay? Because all you had to do was multiply the angle by 18, and 3 goes into 18 6 times, and you'd get the answer. Anyways, it will be easy. But that would just give you x to the 18th, but that will give you 1, by the way, and then 1 plus 1 would be 2. Make sense? Okay, so that would be another method, probably the fourth method. Let's go ahead and talk about the third method real quick, and then we'll finish up. So we are given x plus 1 over x equals -1, and we're supposed to evaluate the following. So this method actually kind of works off of the idea of non-real complex numbers in polar form. But anyway, so remember we got an equation like this, right, from here. We already know that. So here I'm going to do a little bit of math and magic, like hocus pocus. Multiply both sides of this by x minus 1. And obviously I have to assume x does not equal 1 because it doesn't satisfy the original equation. So x does not equal 1, I can multiply both sides by x minus 1 because it's not 0. So now I get a difference of 2 cubes from the left hand side, which is awesome, and this gives you the awesomest result you could ever get. X cubed equals 1. Isn't that cool? And from here I need x to the power 18, which is x to the power 3 to the power 6, which is 1. So x to the power 18 plus 1 over x to the power 18 is 1 plus 1, just like the complex version, and that is equal to 2. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.